Hello, welcome to the final video of the series section of the high-level topic 9 calculus part. So I'm going to apply the things that we've learned about Maclaurin and Taylor series and power series and all that stuff. I'm going to apply it to two things, integration and limits. Let's see how it's done. If you ever try to integrate this thing, you can't. It's a good thing to give to somebody as a trick. Hey, try integrating this. They won't be able to. But you can only do it if you know about Maclaurin and Taylor series. So you know the cosine of x is equal to 1 minus x squared divided by 2 factorial plus x to the power of 4 divided by 4 factorial and so on. Alternating the signs, plus, minus, etc. So I can write the integration of cosine of x squared as, well, the series. Tapping x squared where the x used to be. And just by multiplying the exponents, I know that it's going to be this. Now here I can write this in the general term, right? So this x here is to the power of 0, then to the power of 4, then to the power of 8, divided by 0 factorial, 2 factorial, 4 factorial. So I can write it as a series, a sum to infinity, because that's how it is. And I will be able to do the following thing. I will be able to say, well, the integration of this thing, because I know that this is just a sum of things, right? It's just a sum of first element, second element, etc. And I know that the integration of the sum of an element of elements is just going to be integration of the first part plus the integration of the second part and so on. I can write this thing like this. And now I can integrate. And I integrate, and this is, well, before I integrate, I can take this constant out of the integration, and now I can integrate. And this is what I get, and I got rid of that integration. Pretty neat. So finally, this is the solution. This is the solution to this expression that I couldn't calculate before, thanks to Maclaurin series. How do I use these in limits? Let's take a look at that. Suppose that I have to calculate this limit here. Now, I could calculate this simply using L'Hopital's rule. But perhaps they will ask us specifically to use limits for this. Let's solve it. Well, the limit as x goes to 0 of sine of x minus x divided by x cubed, let me just write sine of x as its Maclaurin expansion. And this x will cancel out with this minus x, and this is what I'll be left with. And now I can start canceling out some of the x to the power of 3's. And this is what I'm going to end up with. Now, since x goes to 0, very quickly, all of these go to 0. So I'm going to end up with minus 1 over 3 factorial, which is minus 1/6. And that's actually kind of a quick way to find the limit of this function. So not very difficult, but I can actually use Maclaurin series to solve limits. It's useful and it's quick, and they probably would like to see some of this. Let's go perhaps for something that looks more like an exam question. They might ask us to find a series expansion of something like this, e to the power of x minus e to the power of minus x divided by x. They might do that. And if they ask us to do that, well, we can combine known series in the formula booklet. Yeah, this is what we have. So let's combine it. I'm going to get this big thing in the top, right? All of it divided by x. But now, if you think about it, well, this one is going to subtract with this one here, and it's going to go away. This x, however, is going to end up adding x. I'm going to end up with 2x. The x squared, well, I'm going to end up with a positive here, so it's going to cancel each other out. You see the way this is going. There's going to be some serious cancellations going on here. So the result is going to be this expression. And now I'm dividing by x, right? So this x will go with this x, etc., 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 etc. This is what the series expansion of this thing here looks like. And if I have to calculate the limit, well, I use the series expansion, and the moment I put an x to be 0 here, all of these are going to cancel away. So I'm going to be left with 2, which is the solution to this exercise. Thank you very much for watching this whole part on the series. I hope it was helpful. Goodbye.